All right, so welcome everyone. This is our July IT&I Information Technology and Interoperability call. This is with ESIP's IT&I Committee and the USGS Community for Data Integration, CDI. And today we're going to be digging into GeoZarr and some updates. Brianna Pagán is going to be sharing her presentation with us today. So feel free to pop any questions that you have into the chat, and we will have, I'm sure, a lively discussion. So Brianna, go ahead and take it away.
Yeah, thanks, Allison. I'm going to go ahead and share my screen really quick. And yeah, I know we have the hour, but I don't expect this to take more than half an hour on a presentation side. I would love to go into maybe more technical discussion. This is a technical committee, so I've been pretty excited to geek out a bit. Like Allison said, my name is Brianna Pagán, and I actually work at one of the data centers at NASA. I work at Goddard Space Flight Center at GeoZarr. It's one of the 12 data centers. I'm a deputy manager there, and we have a pretty large team, about 70 domain scientists, software engineers, and we're basically the people who distribute NASA data to the public, one of the entities that does this. But today I'm not wearing necessarily my NASA hat. I'm wearing my hat as one of the co-chairs of the OGC steering working group on GeoZarr. And I'm going to keep it like pretty high level, maybe on the background of Zarr, but I wasn't sure people's comfort or exposure to Zarr previously. At the last ESIP meeting in person, I did give sort of a pitch talk. We had a cloud native geospatial breakout group last summer. And if you were in one of my huddles, then you would have been maybe a bit more exposed to Zarr. But if you have any questions on just the background of it, let me know. Okay, so to give some context, Zarr itself was created to be a more simple, hackable data format back in 2015 for just n-dimensional data, right? The initial implementation was in Python, but now it's implemented in many different languages, and it's also shifted to a community model that's run by a person named Sankit Varma. What makes Zarr this like hackable data format is the same thing that makes anything ideally cloud native geospatial optimized format. And it's essentially that you can take a cube of data, chunk that data in some meaningful way, and map that desired selection of data to those chunks, right? So the whole idea of cloud native geospatial is that I should be able to map a sub-selection of my data and only pull basically the minimum amount of data without having to access the entire data set. So it was partially created and based on the HDF5 conceptual model, in that there's just multiple arrays that are organized into a hierarchy of groups. But if you're wondering, why did folks back then not just use HDF5? At the time of the creation of Zarr, HDF5 could not do parallel writes with compression, and there was no cloud native support. So that's the genesis of Zarr. But I will say Zarr is beyond just a data format, and I'm going to give some examples of why we see that. But I'm using specifically the term community model and trying to shift people's thinking from beyond that. This is just a data file format type for cloud native data. So going down the timeline here, like I mentioned, Zarr is for n-dimensional data. There's nothing inherently geospatial about storing data in Zarrs. Fast forward to about January 2022, ESA contracted with a company asking to make a cloud native geospatial data cube. This company, which my co-chair Christophe Noel was a part of, Spacebell, was looking at the time of leveraging cloud optimized geotiffs, or COGS, but they realized that COGS did not have the functionalities for holding data that's more typically like NetCDF style data. So also trying to optimize things through time, not just single snapshot satellite images. And so this company decided to look into leveraging Zarrs and realized there was no geospatial convention associated with Zarr. And so at the time, Christophe just did a very quick specification where he basically just adopted CF standards and called this GeoZarr. And it sort of went untouched since 2022. At the same time, the Zarr format itself was made and approved to be an OGC Community Standard. So again, I'm making the distinction that Zarr is nothing inherently geospatial. That was adopted as an OGC Community Standard, but not a geospatial specification because nothing was really unified, right? It was just one person kind of putting some information in a repo and left there. Fast forward 1 year later, January of last year, I had basically reached out to the Zarr community because at the data center that I work at NASA, we were starting to produce and we wanted to release public Zarr stores. And as a data center provider, we wanted to make sure that the metadata was meeting whatever community standards were out there. And we found nothing, right? We found this, we referred to this one repo that was made a few years ago by a single person at a company, and there was nothing formalized. And so in reaching out to the Zarr community, people like Ryan Abernathy and Christophe Noel, we decided to have pretty informal bi-weekly GeoZarr meetings. And our hope was that we would be able to come to some consensus as a community and do something similar in proposing an OGC Community Standards Working Group. So for people who don't know the difference, when you propose a community standard, you're essentially already bringing something fully fleshed out, and OGC just gives a check mark of approval. That is in entirely different route is going through the typical steering working group or a SWG. A SWG process is sort of your initial step into OGC, and that's really kind of assuming that you're starting from scratch. So we were hoping that there would be enough community enthusiasm that we would be able to, take the repository that was created a few years ago, do some basic uplifts and submit it as a community standard. But as I'm about to explain, it was not that simple for some technical reasons. And we decided that we needed some level of essentially bureaucracy and help in making some decisions on here. I'm going to go in a bit more detail. But last November, we submitted and were officially recognized as an official OGC steering working group. And now we are in the process of drafting our charter and actually releasing a specification. So why GeoZarr and why now? Like I said, I'm just one of probably the many data centers that are looking into trying to host data in cloud optimized ways. And we're seeing Zarrs as being increasingly used and considered for data archives. But the issue is that the format itself is still very new. And so there's still a ton of open technical questions around just common geospatial use cases for Zarrs. And in addition, there's still a ton of work to be figured out on how to ensure there's interoperability with Zarrs and traditional geospatial tools like ArcGIS, GDAL, etc. So as of last January, as I mentioned, we started these originally informal biweekly meetings, and we had an amazing turnout of lots of people from different organizations. And I think this is just a testament of people really wanting to understand and see how they could leverage Zarr in their organizations and for their companies. So we've had people from NASA, ESA, Elma84, DevSeed, etc. And one of the reasons that I said in the beginning of not trying to just look at Zarr as a data format is, for those of you who are familiar with Stack or Stack catalogs, Zarr is beyond just the data format. Zarr is also a way to catalog the data and enables much easier and intuitive searchability of the data set. And I wasn't sure, again, maybe people's comfort level of ever maybe seeing a Zarr store. So I just wanted to pull up an example here where I'm calling a single data collection here at NASA, one of our Zarr stores. And one of the advantages is that I can essentially make it look like I'm grabbing all of the data with a single URL. So this is different from this sort of typical approach of like, I need to know individual granules from satellite data. Instead, I can essentially call the entire archive and have a preview here of, all of the time steps, all the lat and longs of this, for example, really high resolution data set. And so you can imagine then I can use more intuitive calls like subsetting by time or by space without having to leverage any other tools. So just wanted to show that example to kind of hone in that it's beyond just a data format. It's a way to make accessing the data more easier and improve the searchability of the data set. So early on when we started having these meetings, I showed you all of those lists of companies, people coming from all over. And it was pretty exciting because it felt like we were becoming this meeting ground of people that were coming from more NetCDF-like data world and people who are coming from GeoTIFF type data world. And we thought, oh, cool, this is going to be a great meeting ground location for all of us. But it ended up not really being a meeting ground. It ended up being a pretty contentious and very technical, in-depth discussions that were essentially fleshing out the reasons why both communities have issues with each other's, metadata standards. One example is, when Christoph originally wrote the specification, just a single person making some judgment calls, they decided to just adopt CF conventions. And so obviously people who are coming from more TIFF world is saying, hey, like CF doesn't meet our needs because of this. And even beyond just doing a comparison with TIFF and NetCDF, even understanding where Zarr would sort of fall in the hierarchy of, is it coming directly from the CF data model or is it going to be coming from a NetCDF data type itself? So we started having just really technical discussions, honestly, much more philosophical. And it was really roadblocking us and keeping us from moving forward and actually agreeing on a specification that would meet both worlds. One specific example is like us trying to understand how to correctly encode CRS. And I'm a bit sad that David's not here because he was really originally like this very strong voice to represent the GeoTIFF community and understanding their limitations with normal CF conventions. And I want to bring up and kind of walk through an example on the Pangeo forum that really highlights now what we see David was trying to basically warn us about. And this is put together by Ryan, and I'm going to scroll down and show you a response that I had on how we can kind of overcome this. But basically, we are trying to demonstrate why it's very difficult to try to leverage TIFF-like information in the Zarr data format, or basically just using tools like Xarray, which again are a bit more used for CF data. So if I were to make just an empty, really big data cube and I assign it some projection, right, and give it some resolution, I'm going to call that just big data set. And let's say I chunk that big data set and I make subsets of tiles, and I'm just going to pull one of those tiles out of the subset. If I do that, you would think that I could just input this small subset tile back into the big data tile, but it actually doesn't work. If you tried to do that, you would actually see an image like this where there's some filled nans, which is pretty curious, right? And I spent a lot of time thinking about this example because it was a great demonstration of sort of why we needed to actually ask these important questions of what is missing in sort of, let's say, CF kind of convention world to be able to hold TIFF-like data. And so I made my own same example of this. I made a big data cube. I tried to subset it. And then I tried to extract information like the geotransform. And basically what I was showing here is that I can take the geotransform of this big data cube. And if I know that, plus the information around like the number of latitudes and longitudes, I can actually derive the original lat and longs just from the geotransform data and the number of lat longs. I can then recreate the sort of big data set X and Y coordinates. But when I tried to do the same thing that Ryan was showing, where I'm just going to take a single tile, I'm going to try to input it, I see the same error of it's not matching. But when I ask, how much is it not masking, right? Like, why do I have a string of lat and longs that are not precisely equal? When I ask the question of how much they are off, it's something like negative 1.4 to the 10 to the negative 14th. Okay, so incredibly small. This is really floating point inaccuracies. And what I think we haven't really acknowledged in these communities is that in geospatial world, we sort of have circumvented, let's say, these floating point issues by using things like we say method equals nearest. And that allows us to sort of be able to ignore some level of tolerance when we're trying to place, a tile back into the cube. And so this was pretty exciting, let's say, breakthrough for us coming from a Zarr spatial standard, because we basically are able to say now that we can start with using something like CF conventions. And then for data that's more GeoTIFF-like, we can say also store this basic information, like 3 empirical pieces of information. One of them would be the geotransform. The second would be, basically the length of the lat long arrays. And then 4 chunks, this chunk reference index. So this is pretty big and late breaking update that I hopefully is going to unblock us from some of this work. And again, this is really coming from, yes, Zarr, the standard and the spec itself can work pretty well with NetCDF-like data. We don't want to exclude people coming from GeoTIFF data kind of world. And we think this is a promising way forward to be able to accommodate both data types. Okay, like I said, this sort of update is pretty late breaking. That discussion was originally what roadblocked us. And because we were just, a group coming from open source community, coming from a ton of different organizations, we did not really have a mechanism of making decisions back then, right? It was sort of, few people thought we should do it this way, a few people thought we should do it that way. And so we decided to just go ahead and propose GeoZarr as a standards working group through OGC. And that also, I think, caused a bit of a rift, understandably so, because, OGC itself can be preventative for different organizations or people to actually get involved. And people were concerned if we would basically leave voices out of the conversation for people representing either themselves or companies that were not part of the OGC process. Just an example of, looking at OGC documentation, once you have a subgroup, it's really solely up to the chairs of the subgroup to decide who gets to even listen in on the meetings. So for sure, there's, some rules around who can vote, but even for people to be, bystanders, there has to be someone letting that happen. So some people were a bit hesitant to go that route. And I think the more probably common reason people were hesitant is we did not want this to become first a 100-page document without a real implementation. And I'm posting here some, Twitter messages of basically people referring to this happening for other specs, like this tiling schema, where it's great when you have all of these different pieces of the spec written down. But as a developer, right, like I just want a tool that I can throw as our story in and basically check whether or not it's compliant. And early on, we were such a philosophical group. We were talking about, NetCDF hierarchies and, how are we going to hold transforms? It felt like we were a bit losing sight of the implementation side. And so we really wanted to also lean a bit harder on, let's not just talk about, what these potential limitations are. Let's try to actually share Zarr stores. Let's try to open them in geospatial tools. Let's try to understand what works and what doesn't work. And so I'll say that we've sort of taken a middle ground approach where, yes, we are an OGC SWG, but all of our meetings are posted, very openly. We work on GitHub. We have a HackMD for notes. Myself and Christoph are co-chairs, and we warmly welcome anyone to come and give an opinion. It's just when it comes time to actually voting on something, that is when we're restricted and have to abide by those guidelines. So our overall objective of our steering working group is first and foremost compatibility. Again, making sure all of these common tools that people are using, GDAL, GIS, ArcGIS, QGIS, etc., that they're working with Zarr stores. We also want to make sure that we're capturing like many types of different dimension kind of supports. This I had mentioned earlier was like more a bit like Stack, where we can, if we make a good enough GeoZarr specification, it can also help in data discovery. Any sort of uniformity here, common ground would also help in mixing of data. So for example, if I'm trying to combine satellite imagery with weather forecast model data, and both of those are maybe natively originally in different formats. Zarr could be a good meeting ground and make it a bit easier to mix those different types of data. And then last thing, just making sure it's flexible. So I will say we're still quite biased group around Python implementation, but we are starting to get people coming from other communities. We have some one key developer, from example, Julia, starting to join us on our biweekly meetings. And, it's basically just making sure that whatever we're implementing is going to work for other people's preferred coding languages. One thing that we've also outlined in the charter so far is understanding what pieces are going to be part of this key specification and what would be considered just conformance classes. And that term is an OGC term. A conformance class is basically just optional parts of the specification. Right. And so examples of that could be symbology, right? Like for some data sets, people want to be able to also store, color palettes, things like that. Any sort of data set specific encodings, any sort of linked children data sets, that's not going to be applicable for all Zarr stores, but like we recognize that we can give suggestions or what we call on what we call conformance classes. We also want to recognize that there is a lot of similar and existing overlapping group. One of them is the OGC Geodata Cube Standards Working Group, which we only just recently started really discussing with them. Same thing with XCube, which is an X-ray based EO data cube toolkit. Any other folks that have worked on basically data cubes, like there's tons of overlap in what we're trying to conceptually achieve in GeoZarr, and we're currently reaching out. For things like GDAL, there has already been an existing Zarr driver. It's supporting a version 2 specification of Zarr. There's going to be an upcoming Zarr V3. We've also had folks from the NetCDF world create NCZarr. And a little bit more recently is an effort called GeoXarray, which is basically an open source Python library trying to use X-ray type functionalities wrapped around geospatial data workflows. So I have just 2 more things that we've really been focusing on as part of this working group. One has been interoperability. Like I said, our fear is that we are just becoming a little bit too philosophical, and we didn't have any sort of concrete things we can refer to of whether or not our suggestion of the GeoZarr spec is working. And so we are lucky that back in February, the Cloud Native Geospatial Foundation and also Earthmover hosted a Zarr sprint in New York. And one of the focuses of the sprint was just on interoperability. And you can see we were focused, and we're still working on this, on creating 2 different tables, basically just trying to say, like, what are the common tools that people use for geospatial things? And can I write a Zarr store? Can I read it? Can I read a Zarr store locally? Can I read it from S3? Taking it a step further is also like, can I create a Zarr store in GDAL and then read it in QGIS and vice versa? And that's like the table on the right. I'll say one of the more interesting discoveries of this, and I'm happy to show you the different issues in our GitHub repo that show this. ArcGIS happens to have amazing Zarr support. We saw, you're able to drop in a Zarr store, and the visualizations that it's able to do on the fly is pretty impressive. So that's exciting for us to see. If one proprietary software has been able to figure out, how to understand potential geospatial encodings in Zarrs, there's hope for the other ones. Another focus that we've been looking at is creating a GeoZarr validator. And so again, this is just to try to make folks' lives a bit easier, where you're going to want to create a Zarr store and you're going to want to be able to quickly say whether or not it is conforming to the specification. So this is a pretty early draft so far. And it leads to the next slides a bit, because GeoZarr is downstream of Zarr itself. Again, Zarr is for n-dimensional data. There's nothing inherently geospatial about it. GeoZarr sort of comes downstream from Zarr. And so when we're making a validator, we're actually just validating the pieces of a Zarr store that has to do with the geospatial components. But we are working with the Zarr community on this. because we want to kind of leverage how other domain applications have done this for their domains. One of the ways that GeoZarr is sort of connected and downstream from Zarr itself. So the Zarr community puts together things that are called Zarr enhancement proposals, or ZEPs. And there is a ZEP, which is hopefully going to be approved pretty soon, that's trying to just formalize the concept that there should be specific conventions for Zarrs that are, again, domain specific. So one of the other big users of Zarrs is actually like the microscope community and the biology community. So that's interesting. And they actually have been, I think, made much more advanced developments with leveraging Zarr stores. So we're trying to learn from that community, how did you, let's say, overlap your existing specifications that might be relevant in your older file formats within Zarr. This is ZEP 4, once it's finalized, would help kind of standardize how this flow of information is going to be occurring. Another like more concrete example of how this is such a new data format and there's still so many open-ended questions. One of the, I think, things that get people excited for working with Zarrs is the fact that you can do pyramiding, right? Or this multi-scaling, ability to zoom in and out. Now that functionality is also nothing geospatial specific, right? Like that is just a potential advantage of using Zarr itself. But there is no Zarr ZEP, so a Zarr enhancement proposal. There's no Zarr specification for multi-resolution or pyramiding. For geospatial applications, we're very familiar with this, right? Like we already leverage this for COGS and GeoTIFFs. And so we've had people from Carbon Plan and folks from DevSeed working on this project called Impact at NASA that have made pretty great strides of, for example, what I'm showing here, showing a Zarr store on the fly and being able to have this like zoom in and zoom out functionality. So let's say they've essentially figured out a potential solution for pyramiding. What's needed now, though, is they would have to take that suggested schema and actually propose it to the Zarr community. And then we as GeoZarr would adopt it from Zarr. Because again, there's nothing geospatial specific about pyramiding itself. That's a Zarr advantage, but there is no existing specification within Zarr for how to handle pyramiding. So it can feel a little bit convoluted, but we are starting to work, we as in the geospatial community is starting to work also at the Zarr level of making sure that these functionalities are available. And then when we needed to put a layer of geospatial information on top of it, that's where GeoZarr would come in the picture. And yeah, that's it for our updates and a bit of a crash course. I'm happy to take any questions. And if you want to stay informed, we keep, we don't do calendar invitations anymore. We keep a HackMD basically live where you can see our next meeting times and how to join. You can also see all of our old meeting notes. And if you want to take a look at the charter and the draft as it is, this is our GitHub repository. I'll say that it's we've made pretty big strides in the past 2 or 3 months. It took us a long time to get there, and our goal is really to try to have a submitted specification for approval by the end of this calendar year. Yeah, thanks.
Thank you, Brianna. So yeah, so you can just unmute yourself to ask any questions, or you can also post your question on the chat as well.
So I've got a question, but I'm trying to think of how exactly to phrase it. Because I know that you had a slide talking about sort of how, and I've read your post on, I think it was Radiant Earth's blog as well, where you talk a little bit about how GeoZarr is comparing to Stack. having a stack of, say, multiple geotiffs. And I'm wondering if you could just speak a little bit more about sort of the either advantages of GeoZarr or the trade-offs involved there. Because I'm personally coming in much more familiar with the stack ecosystem than the Zarr one.
Yeah, for sure. I mean, so stack gets you to find where the data is, right? It ends there, right? I can leverage stack to actually find the data. Zarr takes it one step further because I can also use Zarr to find the data, like the subset of data, but I can also then open it directly. And maybe it's more clear when I show some like concrete examples here. Let me go to one of these. Right. So this looks a little bit convoluted because we've basically made searching our Zarr stores available in CMR for people who are used to working in NASA data. That's our common metadata repository. But all you need to know is I have already extracted like some link of where my Zarr is living on S3. And I can just call that link and already grab, let's say, the data I want. Right. Like that's in one flow. Stack just lets you like search for the data and then you like call the data itself. So that's why Zarr is a bit beyond just the searchability. Like it is also a file format, and that I can touch the data and I can actually use information from this endpoint. Whereas the stack endpoint is just a catalog, the endpoint of the Zarr is the data itself. And this is becoming even challenging managing at a NASA side because we're not used to thinking of data that way. We're like, the catalog and the data itself is one thing in Zarr, if that makes sense.
Yeah, thank you. I have so many follow-ups, but I see a question in the chat, so I'll try and not monopolize your time.
Yeah.
Yeah, there is a question in the chat.
Yeah, so curious if you've been discussing some of these issues with GeoParquet folks, vector analog, issues are just so removed at the two standards. To be honest, I have not been engaged personally with GeoParquet folks. Like if there's some overlap in, you know, them also trying to figure out how to kind of unite TIFF metadata and NetCDF data, I would love, yeah, to learn more and to learn from what they've been doing. Even in the GeoDataCube working group, that also still feels quite GeoTIFF heavy. And it's just a kind of a coincidence that my data center, you know, we're working primarily with NetCDFs. So we're a bit biased there, but we don't want to, you know, exclude folks. Originally, we thought we were going to have no middle ground here with TIFF-like community, but now we're really pushing for it through the blog post, you know, that I just shared here. And maybe just to get a little bit more technical for people who are interested in this kind of side of geeking out on data formats, one of the downsides of using like CF conventions is that you have to explicitly have every single lat and longitude stated, right? So I have like an array of every single lat and long. Sort of one of the advantages of using GeoTIFF is that I can do that implicitly, which makes it much lighter to be able to access the data. And so when we are trying to leverage tools like Xarray, which are already heavily biased to meeting, you know, CF kind of standards in its implementation, even though it should be agnostic, right? Xarray is also nothing geospatial inherently for it, but the sort of drivers and things that it's supporting is a bit more for CF conventions. There isn't a way in Xarray to hold implicit coordinates. And so if you go through this blog post, we're basically saying, you know, Ryan and Xarray folks are going to build in that functionality that Xarray can accept implicit coordinates instead of just explicit. And we're basically saying for GeoZarr, the implicit coordinates could be this. And this is pretty exciting because this could be applied to CF type data too, right? And like, especially just like these normal lat long grids, there's no reason to explicitly have the whole array of coordinates. You could do that implicitly, and it's a bit more lighter weight. We've had some people come with examples of like a data set being just a few megabytes, but then when you're actually trying to open and load the coordinates, it can become a few gigabytes for that reason.
Okay, I have a question. We were working on Endless Web, which was the time series for water. It would go, remember back in the day, NetCDF had gridded data only, and then they came out with in situ data, which is kind of like what you're talking about. So you could have a single site and with a time series history, like for USGS water data. So the question is, so I've often thought, wouldn't that be great to use NetCDF instead of going to water services at usgs.gov? And the user could get a NetCDF or could go on a Threads server, which I think you just mentioned. Didn't you say TDS? When you said TDS, is that a Threads server?
I didn't, but I am familiar with Threads.
Oh, okay. Anyway, so that would be a format. So with this format, so let's say you could put 1 year's worth of time series data into one file. So if I'm going to input an Endless Web, USGS Endless Web water services, you can go to multi-year, you can go across. So would you want to have like a file for, let's say, water year 24, and then another file for water year 23? Would you still need to separate it into files, or would you just have one gigantic file? And
yeah, so that's a great question. First, I want to say OpenApp and Threads was way ahead of its time because that sort of workflow conceptually is very similar to just what being cloud native is. So like shout out to just like OpenApp protocol and things like Threads. What Zarr allows you to do is it allows you to treat the data like it is one massive data set. So that way you as a user, you don't have to worry whether or not there's a file for 2024 and a file for 2022. This is an example, like I'm just going to call for a single lat long the entire time series for this example data set. And it does that. And it does that with you only having one link, let's say. You only see one URL, and that URL is representing the entire data archive. And so the advantage of this being n-dimensional is that, yes, even in situ data can work in this, right? It doesn't have to be standard lat long grids or anything like that. And yeah, as someone who I used to work a lot with like FluxNet data, that would have been amazing as a researcher if like FluxNet provided a version that, was stored what looked like in a single data cube, right? And then I can know, for example, like different sensor names, what have you, I'd be able to pull that. But that's just sort of the advantage of using Zarr itself, is that all of this data is originally, that I'm showing here, were originally NetCDFs, but we've cloud optimized them as Zarrs. So that way, again, the user isn't having to know every single URL per a date or per an area or a region. You're just looking at a data set that's, the entire cube. And I can do that both in time. I can pool a time series. I can also just pool for a random date in this data cube a visualization for the whole globe for that time step.
okay, thank you.
Yeah, we have more time, but if we don't have any more questions, we can, finish early as well.
So just a quick question about, well, maybe not quick, I don't know. So I'm interested in the metadata that's within the NetCDFs and based specifically like CF compliance. How is that, like, say you have a bunch of NetCDFs and you've chunked them and it's, see if I got this concept right. It's one Zarr, right? And how does that handle the metadata? Like how are you able to like differentiate? Like, so I guess the net CDFs all will have the same metadata to them. Like I just,
Yeah, so that's exactly what the GeoZarr is trying to solve, right? So we are, I don't like just saying that Zarr is a data file format, but you can think of it like that. This is a new data file format. So just like there's CF compliance checkers, there will be Zarr compliance checkers, because even though the legacy format could be NetCDF, it could have been HDF5, those are legacy formats that we're considering, and you can convert them into this cloud optimized version. And one of the original reasons why, Christophe, when he did his first guess of coming up with a specification, he just adopted CF conventions. So originally there was no different in being CF compliant or being Zarr compliant. We just did the mapping kind of one-to-one, right? And so whatever CF said, how you're going to label array dimensions, we're going to use that for Zarr. But we had people coming, like David, coming from the TIFF community and saying, hey, I don't want to be excluded. Like, I want to also leverage Zarr. It's very powerful. It's for n-dimensional data. You can't just leave us out. And that's when we sort of got roadblocked of like, oh, okay, well, now we need for it to be CF compliant and kind of TIFF compliant. And we need to know the middle ground. And like, are we going to just have maybe like two subsets of Zarr where it's like, you can check if it's CF compliant or, so it got very, let's say, heated and honestly really confusing, because these are legacy issues, right? There's a reason why not every geospatial thing is CF compliant either, right? Like the TIFF world is a different beast. They have their own standards for their own reasons. And it's been a decades long conversations, I think, trying to learn from each other or trying to, input some of the TIFF things into CF. And it just hasn't happened. And we were sort of becoming the meeting ground and rehashing like decades old threads around, geotransforms and how to store CF encodings, and should we use PROJ or WKT? Like, that's how in the weeds we were going. And right now we're just hoping, if we kind of have tried to abstract this a bit and unify things around this, bare minimum amount of information of like, okay, like the concept of a geotransform or the concept of holding implicit coordinates is relevant for both communities. So let's find a way on how we can hold implicit coordinates for both CF data and TIFF data. So hopefully that helps clarify. It's an abstract problem,
I mean,
I think, that we're having.
Yeah, the issues on this side, it's my kind of new to the Zarr world, and so it's my perspective that I'm looking at it. Like, originally I was thinking of it as like, just, okay, it's one data file, but it's not that. It's like, it's like an indexing system, more like like a library. Yeah, okay,
Exactly.
gotcha.
That's how it presents to the user. Now, in the back end, if you're actually like the data provider, right, you do see like a lot of different files and all of that. But the advantage, I think, is to like the end user, that it presents as just a data cube. It looks like it's one file, but that one file, I'm now able to quickly index with like common geospatial tools, which makes it optimized for the cloud. And I will say, for folks, coming from NetCDF world, there is also something called Kerchunk, where Kerchunk is also basically providing these indexed sidecar files to help also quickly access and map the NetCDF data. So that's new. That came after Zarr, right? I'm kind of thinking like, I wonder if Kerchunk already had existed, if Zarr would have ever come out, because Kerchunk also kind of handles the limitations that keep NetCDFs from being cloud optimized. Kerchunk is another way around that, because that is basically having these sidecar index files to help people quickly map to get their data. So you also don't need to convert necessarily to Zarr. They're coming up with like a word that we're using, like a virtual Zarr store, because we do think conceptually, like for the end user, thinking of it just as a data cube is great, right? Like not having to know the full file path for every year, every time step, that's very much more intuitive, I think, for the average end user of this data. And so even using something like you're using Kerchunk with NetCDF, but we're going to call it like a virtual Zarr store, because we could present it as like one URL kind of looking thing to an end user.
Great, thanks.
Is there any more question? If there is no other question, we can actually end the meeting. I think there is no other question. So thank you, Brianna, for your great presentation. It was very interesting. And thank you all for joining this afternoon, and hope to see you all in our next meeting next month. So thank you very much, Brianna.
Yeah, thanks everyone. Talk to you soon.
Thank you, Brianna.